Okay, welcome again on the continuation video of differentiation. The last video actually explained a lot of things on differentiation. So if you want to know the beginning and introduction part of it, I'd like you to actually look at that. But today I'm going to continue from second differentiation. That means when you are second order differentiation, when you have differentiated it, then you have to differentiate it again. So if you look at it, the y dx is what you use to differentiate the first integral. So the second integral is when you now differentiate your answer after the first differentiation twice. So um, for example, now you have this question, 3x raised to the power 5 plus 4x raised to the power 2. Following the laws of differentiation, remember what I say about differentiation. All you need to do is the power, you subtract 1 from the power, and the power you use it to multiply the function. So when you differentiate this, it's going to give you 3. If you differentiate this, okay, it's going to give you 3x raised to the power 5. No, when you differentiate it, remember, you have to rewrite it to make it easy for you. So when you differentiate, you now become 15x raised to the power 4 minus 8x raised to the power 3. How did that 4 turn to 8? When you have minus 2 times 4, it will give you minus 8. Now, this is the first differentiation. Now, second differentiation now, you differentiate the answer that you have gotten. So again, so that is the second order differentiation. Another example is this. You can also remember 3 root x is the same thing as 3 raised to the power 3x raised to the power 2, 3x raised to the power half. Then you do your basic differentiation, subtracting 1 from the power, using the power to multiply the coefficient of of it, and voila, you are done. Okay, so let's move on to the second aspect of this, which is the tangent and the normal. The tangent and the normal. What do I mean by the tangent and the normal? Now, if you remember during your basic or coordinate geometry, when there are two lines that are parallel to each other, we say that their gradients are equal. Their gradients are equal. But when they are perpendicular to each other, we say that the gradient of one, the multiplication of their gradient will give you -1, which means that the gradient of one is negative inverse of the other. So, but when you bring that analogy to the curve and a straight line. The first under coordinate geometry is just two straight lines. But now when you have the curve and a straight line, there are two things that we talk about there: the normal and the tangent. Because when a line touches a curve in one place, like what you have here, is called a tangent. But when a line crosses a line like that in a straight line, like this one here, we call it a normal. So these two things is what we are going to be looking at. How we find the equation of the normal or equation of tangent. How do you do that? It's very simple. The steps are simple. Equation of normal and equation of tangent, just like this. What you do is first you find, like look at this example, find the equation of the tangent to the curve at the point 3, 5. Now, this is so easy. So we need the gradient of the tangent. It will be the same as the gradient of the curve at the point 6. So because it's tangent, like I told you, the gradient of in a curve, now listen, let me explain this again. On a straight line, when two parallel lines have the same gradient, and on perpendicular, two parallel lines, the product of two of them will give you -1. Why in a curve and curve, tangent, and the normal? The tangent, the curve will have the same gradient with the straight line. But when it is normal, the curve will have the gradient that you have when they are perpendicular in a straight line. That means the product of the two gradients will give you -1. Now, what do I mean? If I can solve this equation, if I can find the gradient of this curve, then the answer I'm going to get using 1-point formula, remember that, or using your general straight line equation, you can find your other line. Look at this, what happens here. They differentiated, they add 3 to it because it's x, and you find the gradient of the line, curve. The gradient of the curve is 11. This the gradient of the curve is 11 because it's a tangent to the curve, the line, the gradient of that line will also be 11. Then you use the formula for straight line and you find your value. Using 1-point formula, you find the equation that is tangent to the equation. As simple as ABC. Another question again that we'll look at. This is the example of find the equation of the normal to the curve. The same thing you are going to do. Now, this time around, you have to remember that the gradient of the normal of a curve is negative inverse of the gradient of the curve is negative inverse the gradient of the normal of that curve. So what do I mean in a straight line? You differentiate the general differentiation. Remember, when you differentiate a constant, it will give you 0. So we are just going to focus on the -3 root x. Then when you differentiate it, you add the value of x. The answer that you get, that will be the gradient of the curve. So the negative inverse of it will now be -3, -4/3. Then you use that particular one to be able to solve 1-point formula equation, and you get it. Now, another thing again you need to know, in this case, you are not given the value of y value. If you watch my last video, I told you how you can find the coordinate of a point. You are given the y value, the s value of that point. So all you need to do is to put the y value of that point in the equation, and all you need to do is to put the x value to that equation, and you get your y value. Now that you find your y value, you use 1-point formula and solve the equation. It's that easy. Use 1-point formula and find the equation. Now, in summary, when you want to find the equation of a normal to the curve, the equation of a normal to the curve, the gradient of that curve will be negative inverse of the gradient of that line that is normal to that curve. Why? If you're finding the equation of tangent, the gradient of that curve will be the same with the gradient of the tangent, the line that is tangent to that curve. That is actually the basic that is between this differentiation. I want you to understand that again. I would have loved to give you first principle, but let me explain that again to you. There is a curve and there is another curve. At this point, there is a normal, this is a normal, and this is a tangent. This is a tangent. So when there is a tangent, there are two things here. This have capital letter gradient, this have small letter gradient. In this case here, this have capital letter gradient, and this have small letter gradient. At the normal, the gradient of m will be equal to -1/m. While at the tangent, the gradient of capital letter N will be equal to small letter m. So when they say find the equation of the normal, now, at this case, this is the normal, and this is tangent. So when they ask you to find the equation, that means what I'm trying to say is this: they give you the equation of the curve and ask you to find the equation of the line. What you do is that you differentiate the curve, find the gradient, then you use the gradient with the point given to you to find the equation of the line using 1 point formula and getting this equation. Y is equal to mx plus c. And 1 point formula is y minus y1 is equal to m in bracket x minus x1, where y1 and the x1 is the point of intersection between the curve and the line, while m is the gradient. I will stop here. I'll click and watch my other videos. Remember to like and subscribe my videos. Thank you so much for being there. You're welcome.